Alright, a gas has a pressure of 0.370 atmospheres at 50.0 degrees Celsius. What is the pressure at standard temperature? So, first thing that we need to do is write down our equation. So we have P1V1 over N1T1 equals P2V2 over N2T2. So now that we have that, now we need to identify what is listed in the problem, what's given to us. Okay, so we have, looks like we have a pressure right here. So we have a pressure, we have a temperature, and looks like I don't have anything else, but I am going to change the temperature because it says at standard temperature, which means I'm changing the temperature, and I want to know what the new pressure is. So it looks like I'm going to have another pressure and then another temperature. So my first pressure is going to be 0.370 atmospheres. And then my first temperature is going to be 50 degrees Celsius, or 50.0 degrees Celsius. And then my new pressure is what I'm looking for because I'm asking for pressure. My new temperature is standard temperature, which is 273 Kelvin. So that's all that's given, and since nothing else is mentioned, we can make the assumption that everything else, or all the other properties of the gas, are going to be constant. So volume is constant, and number of moles are constant because they're not even mentioned in the problem. So my equation now looks like this. P1T1 equals P2T2, oops, 2, which I can, if I do my cross multiplication, I'm going to end up with P1T2 equals P2T1. And that just makes it easier to isolate your variables so you don't have to multiply by your reciprocals or anything like that. So now I move back and I need to just plug in my answers or plug in my numbers. So my first pressure is going to be 0, so right here, 0.370 atmospheres. Remember to make sure you always include your units. And I'm going to also have my temperature, or sorry, my second temperature, which is 273 Kelvin. All right, now I'm going to go ahead and make some room and say that we'll kind of work backwards here. My second pressure, which is X, and then my first temperature is 50 degrees Celsius, which, like I've said, you always want to make sure you convert your Celsius to Kelvin. So this isn't going to be in 50, this isn't going to be 50 degrees Celsius. We need to rewrite it as Kelvin, which would be Celsius plus 273, and that would be 323 Kelvin. So that's 323 Kelvin, which this will go right here, 323 Kelvin. Okay, so now that I have the problem set up, let's go ahead and let's erase this right here just because it's in the way. All right, now I'm going to isolate my variable, which is X right here. So I divide both sides by 323 Kelvin. Divide this by 323 Kelvin. Now, this whole thing here is going to cancel out. That and that. So that's gone. So now I just have X over here. But here, the only thing that's going to cancel out is going to be my Kelvin, which is okay because I want to make sure that I have my unit of atmospheres. All right? So what I'm really going to end up having is, let's see, if you want to just do the top multiplication first and then do your bottom division. So you would have 0.370 atmospheres times 273, and then divide that by 323, since your units are now gone. So if you do that math, so 101 over, okay, because 101 comes from 0.370 times 273, the 101, I need to make sure I keep 3 sig figs, divide that by 323, and my answer ends up being 0.314 26, which would mean it would be 3, and my unit is atmospheres. So there is my answer. That's going to happen to the pressure if I was to take the temperature up to, or down to standard. Now, if we were to take a look at Gay-Lussac's law, which says that if the number of moles and the volume is constant, that if the pressure goes up, the temperature goes up, and if the pressure goes down, the temperature goes down, and vice versa. So let's go ahead and take a look. What did happen? So my pressure, I didn't, or that's the one I'm looking at. The one that I changed was my temperature. My temperature went from 323 to 273. So my temperature went down, and of course, according to the law, if the temperature goes down, then my pressure must also go down. And if you look, pressure of 370 right here, atmospheres, 0.370 atmospheres, my answer should be less than that. And it was 0.313. All right, let's go ahead and take a look at another problem. So a gas has a pressure of 699.0 millimeters of mercury at 40 degrees Celsius. What is the temperature at standard pressure? Now, remember from a previous video, we have standard pressure, which is going to be 1 atmosphere, or 1.00 atmospheres. But since we're dealing with millimeters of mercury now, the standard pressure is going to be in millimeters of mercury, not in atmospheres. Step 1, always write it out. P1 V1 over N1 T1 equals P2 V2 over N1 or N2 T2. All right, now let's go and take a look and see what we have. We have a pressure unit. We have a temperature unit. All right, looks like, and that looks like what we have. We have a pressure and a temperature. So this is going to be another Gay-Lussac's problem. So since my volume and number of moles was never even mentioned in the problem, I can go ahead and assume that they are constant, which means this guy right here I can rewrite as P1 T1 equals P2 V2. Oops, not T. V. What do this? T2, which I can rearrange this yet again by doing the cross multiplication. Like I said, I highly recommend you do this. You don't have to do the cross multiplication, but it does make it easier to isolate your variables. Okay, so you'd have P1 times T2 equals T1 times P2. Okay, but now I need to fill in my numbers. I need to know what my variables are in the first place. So 1, 1, 2, 2. My first pressure is 699.0, that's 4 sig figs, millimeters of mercury. My first temperature is 40 degrees Celsius, or 40.0 degrees Celsius, which we might as well just do it now and convert that into Kelvin, because we're going to do it anyways. So 40 plus 273 is going to be 313 Kelvin, so 313 Kelvin. My second pressure is standard. My standard pressure, which remember in the standard pressure in millimeters of mercury is 760.0 millimeters of mercury. Okay? And then your T2 is what you're solving for. Okay? Now, we now take these guys and plug them into that equation right there. So your pressure 1, which is going to be 699.0 millimeters of mercury. Remember, always have your units in there. And then multiply that by T2, which is X, and that's going to be equal to T1, which is 313 Kelvin, and that's going to be multiplied by 760.0 millimeters mercury. Okay, it gets kind of squished down there. But now I'm going to divide both sides because I want to get X by itself. I'm going to divide both sides by 699. Let's go ahead and get rid of that. 699.0 millimeters of mercury. So 699.0 99.0 millimeters of mercury. Okay, that causes this whole thing right here to cancel out, and it also cancels out the millimeters of mercury unit. So now, all that I have left is X is equal to 313 Kelvin times 760.0 divided by 699.0. Alright, you do the math. X equals 340 decimal, don't forget your decimal because you need 3 sig figs, Kelvin. Okay, so these two problems right here just happen to be Gay-Lussac's problems, and then take a look at another video and see if we can figure out what type of law is in the other videos.